Hello everyone. So this is the last week and the last chapter. The last chapter that we are going to talk about is data structure, and in the data structure we are going to talk about the linked list. So just a summary or just an introduction to the data list. A linked list. So a linked list data structure. So what is a linked list? Linked list is a data structure. It consists of capsules, or you can say the data, capsules of data known as nodes. So linked list consists of the nodes that are connected to each other with the help of links. So links can be viewed as the connecting arrows and thought of as one-way passage from one node to the another. In Java, nodes are realized as objects of a node class. So whatever the nodes we create in linked list, they are the objects of the node class, and the data in the node is stored with the help of the instance variables. Links are realized as a reference. So references are something which store memory address. So reference is a memory address and is stored in a variable of a class. So link is an instance variable of the node class, of the class node itself. Now why do we need linked list? The important points of about Java linked list are: Java linked list can contain duplicate elements, it maintains the insertion order, it's non-synchronized, and manipulation is fast because no shifting is needed, and it can be used as a list, it can be used as a stack, it can be used as a queue. The simplest kind of linked list data structure is a linked list. We are going to talk about singly linked list. Although we have singly linked list, doubly linked list, and circular linked list, we are going to only talk about singly linked list. So a linked list consists of a single chain of nodes, something like this, These are the chain of nodes which are connected to each other with the help of the link. So the first node is connected to second with the help of a link, second is connected to third with the help of a link. The first node is called the head node, and the last node is served as a end marker. So if you see over here, we have head is just a pointer which points to the first node. So let's go back. Node. What is a node? Nodes are the objects of the node class, and data is stored in a node with the help of the instance variable. So nodes basically store the data, and they are connected to each other with the help of the link. So these are the links. So the top node, this is called as the first node, this is the last node. So first node has a pointer which is called as the head pointer. This pointer points to the first node in the linked list. And if you see over here, a linked list has a name and it has a data value. The node has a name and data value. This is the data that it stores. The node stores the data. This node stores this data. And the last node has a end marker. End marker is usually denoted by slash, which denotes that there is no other node after this. So head, if a head points to any node, that means that is the first node. If a node contains the end marker, that means that is the last node. There is no node after this. So in a linked list, each node is an object of the node class, and each node is typically illustrated as a box containing one or more pieces of data, and each node contains data and a link to another node. So piece of data is an instance variable, data is represented, you can just think of it as a box, and links are implemented as a reference to the node, and the links are illustrated as arrows that point from the previous node to the next node. Alright, now coming to the programming part. So every node is a part of the class node. So first of all, we need to define a node class. So we have a class node here. We can define any type of methods in the node class. Now if you see, we have declared a variable of the node 1 type, of a class type. So this link is a variable of a class type, node 1 type. So this will contain a reference to another node. That reference is the link to the next node. Now what we have done, we have created a parameterless constructor, and link is initialized to null, item is initialized to null, and count to 0. That means we do not have any link, we do not have any item, and number of nodes are 0. Then we have another constructor. In this we have passed 3 parameters. We pass item, we pass the count, and we pass the link value. And here we are calling the set data method. So this is the set data. Set data, we are going to set the data on a node. So we are passing 2 parameters over here, new item, and we are going to new count value. Then the last one is the set link, and where we are setting the link. So these are the few methods of the node class which are given. Although you can have more methods based on your requirements, but I am going to discuss just very summarized version of the linked list. So if you see over here, there are more methods given over here, like set data. I have done get item, get count, and get link. So which returns the link, count, and the item. The first node or the start node in the linked list is called as the head node. So the first node is called as the head node. The entire linked list can be traversed by starting at the head node and visiting each node exactly once. There is typically a variable of the node type which is called head that contains a reference to the first node in the linked list. So we have a variable called head, and it contains a reference to the first node. Reference means it contains a link to the first node in the linked list. However, it is not the head node, nor it's a node, it is just a link. It contains the reference to the head node. A linked list object contains the variable head as instance variable. Linked list object does not contain all the nodes in the linked list directly. So variable head is used to locate the head node of the list. The head instance variable contains a reference to the first node. So it contains the reference or the link to the first node. If the list is empty, the instance variable is set to null, and we can test it by using a equal to operator or not equals method. The linked list constructor sets the head instance variable to null, and which indicates that newly created linked list is empty. Alright, so coming to over here, so we have another variable of the, now we are creating a linked list class. Alright, so what we are doing over here, we create a variable of the node class which is head. Now we initialize the head to null because we have not created any list. So this is a instance variable. This is not the head. Head is the first node in the linked list is called the head, and head variable, this is just a pointer, this is just a reference. So don't confuse the head node with the variable head. So if we want to add the node at the start of the list with the specified data, we have this method add to start. So we pass 2 parameters, item name and the count also. So in the head we just pass item name, item count, and the head. If you can recall, I have a constructor in the node 1 with 3 parameters. If I go back, this one, so we need to add a node over here. Alright, going ahead. Delete the head node. So we want to remove the head node. I am removing the head node. So it returns true if the list has at least one node, and it will return false if the list is empty. So if the head is not equal to null, it will get the link and it will return true, otherwise it will false. So it's a Boolean method. Size, it returns the number of nodes in the list. And the last node is indicated by the not equal to null. So we want to get, while position is not equal to null, it should count how many links are there or how many nodes are there. So if we want to find a particular item, we have the Boolean method contain, and we are passing the variable as a string type. So it will return if it finds the item and it's not equal to null. Find the first node containing the target item and return. So we may have the same value in multiple nodes, but this method is used to return the first node to find the target item. Okay, going ahead now. Get item method is used to traverse the list. So if you see, if we want to search for some value, search for some item, we start with the head. That means we have a variable called position. We put the head over there. Then we use the while loop. While position is not equal to null, so we need to traverse the list. I have this list. I need to travel all the lists. So position dot get item, it will get the item and it will put it in this variable. Now whatever the item is here, if it is equal to the target value we have passed over here. If it is equal to the target value, it will return the position, and position dot get link, position will have that particular ring. Otherwise it will return null, that it's not found. If we want to produce the output list, we want to print all the items, we have the method output list. So get item method is used to print all the items or all the nodes. Indicating the end of the list, we can use null or not equals method, as I told you before. Traversing a list, if a linked list already contains node, it can be traversed as follows. We use the local variable equal to the value, and then we provide the location of the first node. After accessing the first node, accessor method will provide the location of the next node, and we repeat it. So if you see over here, head, this is the variable and this is the head node. This is the last node, null is the variable or the pointer. So position, get link position, position dot get link. So this is the get link. When position is at last node, position dot get link is equals to null. So link will have the null value. So this is what we mean by the null value. So get link, it will go to the next link. So when the get link has the null value, it is equal to null. So at that time my iteration will stop. Adding a node, if we want to add a node to a linked list, so we have the add method, and we are going to add at the start of the linked list. We are not going to add it anywhere. So now the new node will become the first node. So variable head gives the location of the current first node, and when the new node is created, its link field is set equal to head, and head is set equal to the new node. These are very two important points. When new node is created, its link field is set equal to head, and head is set equal to the new node. So for example, over here, initially we have this as the head node. Now if we want to add a node at the start, what happens over here, it creates this node and it will position it here, and now what it will do, the head which was pointing to this node, the head will point to the first node over here, and it will create a link to the next node. So this is quite important point. Delete head node. If we want to delete the head node, what we need to do, we will first remove the first node from the linked list, and then we will move the head variable. It will leave the head variable pointing to the null. So then we need to make the head variable point to the next node, which is the second node, and the deleted node will automatically be collected in the memory cycle, which is called as the garbage collection. So for example, if we want to delete this node, what we need to do, we set this reference, we delete this node, and then this head, we need to make it point to the next node, and we need to delete this next link also. So these are the changes that we need to do when if we want to delete the node. Alright, I am going to create an example based on this example which is given in your book, but I am going to create it in my own way with few methods and in a much easier way. Alright, an important point to note over here, that linked list class, we created it as an independent class, but normally it is preferred to make it as an inner class, and the inner class defined should be made private unless elsewhere. So why the original node and the linked list class examined have a dangerous flaw. node class and sister method returns a reference to the node, there can be the privacy links. So if you see over here, this is an example in which the inner node has been made as a private inner class. So it makes no difference whether we make the instance variable of the node as private or the public. So this is an inner class for the node class, and my inner class, okay, my inner class, yes, my inner class ends over here. So we have just only two constructors over here. So after this we have the method. So this class has been simplified, and the previous link class it is like kept short of it. So it's better to have the it as a inner class. The outer class has a direct access to the inner class instance variable, which is the link. So it's better to create it as a private class. So that's all about the linked list. Now I'm going to create a very simple program using what is given in your book, but I will keep it as simple as possible. Alright, so let's create it. Okay, let me make a Java file. Okay, let me define the path. I will define the path over here. First of all, I want to make it on the desktop 231. Okay, and this is week 15. Okay, so let me give it a name, node 1 maybe, or node, whatever you want to give. I'm not going to make it as an inner class, rather I'm going to make it as a separate class, but you should try to make it as an inner class so as to avoid any private. You can try yourself by making it as an inner class. Public class node 1. Now I'm going to declare the fields as private string item. I'm going to make that example much shorter and in my own way. And let's have a int method which is called count, and we have a variable of class node type, we call it as a link. Alright, now we define the constructor public node 1, and let me pass over here the three variables: string new item, because I will initialize it, int new count, and node 1 link value. So what are we going to do over here? We are going to initialize it. Item is equals to new item. I'm not going to use any set methods over here. Just very simple, in a very simple terms, I am going to make this program is equals to new count, link is equals to link value. Alright, now I am going to make a string method public string get item to get the item, because it's a private variable. So what I will do, return item, just return me the value in the node, count public get public int get count, so return count, and the last one is get link public node 1. It will have a return type of node 1 class type, get link, sorry, So return link. Let's just compile it. Okay, now let's create another class, a linked list class, where I'm going to make more methods like adding the item. I have just created a node class over here. Now I need to create the methods like adding a node, deleting a node, or showing, counting, all the methods I need to create it. So let me create a class, linked list 1 maybe. Okay, public class linked list 1. Alright, now I am going to create a variable of node1 type, and let me call this variable as head, instance variable, because I need to have a head variable. Now in this I am going to create the methods adding a node to the start, deleting the head node, and then returning the size and the output list method. These are 3 or 4 methods. I am going to create it over here. So let's create the method public void add to start. And for adding a node, what I need an item name and I need item count also, because item count should be incremented. Item name followed by int item count. I'm doing the same program which is given in your book, but in my own way. So head is equals to, remember I have a constructor new node1. So I'm going to call this method, is equals to new node1, new node 1, and I need to pass 3 parameters over here. And what are those parameters? Item name, item count, and the third parameter is class type, and I call that as head. Alright, so this is complete. I will add it to the head of the node. Alright, now let's create a boolean method delete head node. Delete head node. I am not going to delete any other node except the head node to make it simpler. Delete head node. So what I have to check, if head is, because if head is equals to null, that means I do not have any list. So if head is not equal to null, what will I do? Head is equals to head dot get link method. I'll call the get link. It will return me the link. It will return true. And if it is the head node, what it will do, this will delete the link. It will delete the link, get the link, and it will delete it. It will return true. Otherwise, if it is the head node, it will return me false. Let's create another method which is called size. So size should have integer type, int size method. Alright, so initially what we do, we declare a variable called count. We initialize it to 0. Then what we do, we create a variable of node1 type. We call it as position, and we store whatever the value head has in a variable of class type, which we call it as position. Alright, now we use the while loop to check while the value in the position is not equal to null. So what it should do, it should increment the count. So while value in this position is not equal to null, it should increment the count, and in the position it should get the link. Position is equals to position dot get link. Let me check the get link method. Yes, I have the small. Alright, and after this it will return count. Alright, after this size method, let's have last method, output list. Just to display all the elements in my linked list, output list. So same way I create node 1 position is equals to head, whatever is in head I just do it. Now again I have to traverse it because I need to traverse, right? While position is not equal to null. Now here for traversing, remember I will use the get item method. So system.out.println position dot get item method, right? Position dot get item method, and I will return the count also, plus position dot get count. Let me just use the get count also, get count method also. I have it. Yeah, I have it. Okay. Alright. Then what we do? We just get the link. Position is equals to position dot get link. Alright. Let's just compile it. I have errors. Let me check with the errors. Line 38, last line I guess. Okay. Let me, yeah, here, the error is here. Okay, get link. Let me check this method, ls small. Ls small here. So done. Now let's create our main class. Let's create our main class. So I call it as linked list demo. Public class linked list demo. Public static void main string args. Alright, let's first of all call the add method. Let me make an object. Linked list 1 list is equals to linked list 1. Okay, let's just add first of all data. List dot add to start. Add to start method. So it has item name and count. So I add apples and 1. That means it's a first item. I call it again. Okay, I make it as apple, banana, and the count is 2. Orange, count is 3. Grapes, count is 4. So my head node is now the last one, which is the 4. So because see here, I added the first item. For example, let me just show you how it will work now. I added the first item to the start. Now head points over here. Then I added another item. So this item will go down, which was my apple. Now I have added banana. Banana will come here. I added another item, for example orange. Orange will come here. It will be the top node or the head node. Then I added grape, so it will be the top node. This is how my list will look like. Alright, going back. Let's call other method now. Let's get the size of it. Alright, let's get the size of it first of all. Then I will call another method. So system.out.println. Size should be 4. List has plus list dot size method, right, plus and dash nodes. This is up to you how you can call. You can simply call it. Let's just run it. Okay, I have void and linked list, public class linked list 1. Okay, is equals to new linked list. Alright, let's run it. So the list has 4 nodes, right? Okay, now what we do, let's just call the output list method. Output list, it will get me the item and get their count also. So list dot output list. Alright, so if you see, first item is grapes, start from the bottom, then orange, then banana, then apples, because that was the first item. So when we add to the head, the first item that we added goes to the down. Alright, now let's call the method delete head node. So my head node is grapes and my tail node is apples. So let's just call list dot delete head node. So now my grapes node should be deleted. Alright, because I am not calling the method output list, let me call the method as output list. That's why system.out.println. Let me first of all give a separator. Okay, let me just call this method list.output.list. So now, because I call this method head node, when I call output list method, this grapes should be deleted. Let's just check it. So if you see, now orange becomes the head node over here. Alright. Okay. Let's delete all the nodes while list dot delete head node. I'll make it as an empty loop body. I go over here. Okay, I have over here a method. I want to show you some method over here. with the empty loop body so it will empty the list. When I call like this, it will empty the list. There is no loop body because the method delete head node, it will perform both the action on the list and it will return the boolean value. So it will empty, that means it will delete all the items in the list. Alright, so let's just compile it. Okay, and I call something so as system.out.println start of the list. And what I do after this, I'll call the method output list. It should not show me anything because while list.delete head node, it has deleted all the elements. List.output list, right? Okay, and then I print something again, system.out.println end of the list. So now if you see, I have called this method delete head node. After this, this method, what it's going to do, it will delete all the nodes, and when I call this method output list, I will not have anything, any node. My list will be empty. Let's just check it. So if you see, it just prints start of the list and end of the list. So this is a method to delete all the nodes without making a loop body. We can delete all the items or all the nodes in a list. Linked list is a class which is defined in java.util library. So instead of creating node and linked list, we can directly use the Java linked list library also. Let me just create a test class. But we will not use the library. We don't prefer to use the library, rather we prefer to create our own methods. That's why I created my own methods, but still you can use the library also. I will show you the use of the library. Public class test public static void main string args. So I can create an array list, linked list of string type. I need to create an array list is equals to new linked list. I create an empty array list of the linked list, right? Linked list already has the elements add first, remove first, remove last. So if I call this method list.add apple, alright, and then I call the method list.add banana, alright. Now I call the method list. Now I print it, system.out.println. I print this list. Okay. Sorry, I should have it after this list. Alright. So first item is apple, second item is banana. It's not showing the other way around, just we had in the previous example. Alright, I can add the item to the first position also. For example, if I do list dot add at first position, like grapes, yes, I need to add 1 and grapes. So my item which was at first position will go down, and instead of it grapes will come. Sorry, I have not printed the list. So apple, grapes and banana. So grapes come because banana is at first position, it moves down, and grapes come in the position of banana. If I want to add it to the head, or I want to add it to the first position, so list dot add first. These are all the methods defined in the linked list class. So let me add orange. So now my orange will be the head node instead of apple. Let me print the list also. Let me print the list also. So orange is the head node now. Similarly, I have the add last method. So if I use add last, list dot add last, node will be added. Now I have banana is the last node. It will be added at the last. So for example, I give kiwi. So instead of grapes, now it will be kiwi. That will be the last node. So add last, add first, add method, these are the few methods. So kiwi is the last one. Similarly, we have a remove method also. So system.out.println remove method, so that you know that I am now doing the remove method. So list dot remove. Remove first will remove the first node. So if I first, I need not to provide anything. So orange is the first node. My first node will be deleted. Let's just check it out. So my first node was orange, it is deleted. Similarly, I have remove last also. Another method which I have, list dot remove. Now I need to provide over here the string value. So I need to provide over here the string value. I need to provide over here the position. I can provide the string value also, or I can provide the position any one. So for example, I want 1. At 1 position, I have grapes. Let's print it. So I have grapes is removed. If I want to remove the last node, list dot remove last. So this is how we can remove the last node. So the last node was, I guess, kiwi. It will be removed. Yes. Kiwi. Now with the remove method, either I can provide a position, or I can provide the item name itself, for example BANANA. Now it should be correct, otherwise Now the way you have provided the item name, you need to define over here the same name. Alright, sorry, it should not be list.remove BNNA. Let's just print it. So banana is removed. Alright, so this is how we can do the linked list, how we can create the previous method is preferred and not this one by using the array list. This is not a preferred way. We need to create a node class, then create our own methods and then implement those methods. And the more preferred way is we need to create the node class as the inner class. Inner class, you can make it as a private inner class, and the variables inside the inner class, you can make it private or public, it won't matter. Alright, so that was all about the last chapter, linked list, the methods, important methods in the linked list. So here we finish with the syllabus, and thank you so much.